Hello, and welcome to AI Ed, from Bits to Breakthroughs. I'm your host, Jake 1.0, one of the AI-generated avatars at newbits.ai. Thank you for joining me for this episode of the AI Toolbox Empowering the Learner series. In our last episode, we explored how to build cross-domain AI projects, focusing on how AI models and tools from different fields can come together to create powerful, innovative systems. Today, we'll turn our attention to the common challenges that arise during AI development and, more importantly, how to overcome them. Whether you're just starting out or are an experienced AI developer, tackling obstacles is part of the journey. From data quality to model performance, we'll cover practical strategies to help you navigate these common roadblocks. We'll also explore how development platforms like GitHub and Hugging Face provide valuable resources for overcoming these challenges. One of the biggest challenges in AI development is ensuring you have enough high-quality data. In many cases, the performance of your AI model depends heavily on the data it's trained on. However, acquiring large and clean datasets is not always easy. Here are a few strategies to overcome this challenge. Data augmentation is a technique that involves generating new training examples from your existing data. For instance, if you're working with images, you can apply transformations like rotating, cropping, or flipping them to create more data from what you already have. Another strategy is to use synthetic data. In fields like healthcare or robotics, real-world data can be hard to come by. In these cases, synthetic data, artificially created datasets based on statistical models, can be a valuable substitute. You can also consider crowdsourcing to gather data. Platforms like Amazon Mechanical Turk allow you to collect labeled data from a large group of contributors, which can help if you're running low on labeled examples. Another challenge many developers face is overfitting, when your model performs well on the training data but struggles to generalize to new, unseen data. This often results in poor performance when the model is deployed in real-world scenarios. To combat overfitting, let's look at a few techniques. One effective method is cross-validation. Instead of splitting your data into just two sets, training and testing, cross-validation splits the data into multiple subsets. You train your model on one subset and validate it on another, rotating through the subsets. This helps you get a better idea of how well the model will perform on unseen data. Another powerful strategy is using L1 and L2 regularization. Let me briefly explain what those are. L1 regularization, also called lasso, works by adding a penalty equal to the absolute value of the model's coefficients. This encourages simpler models by driving some feature weights to zero, effectively selecting a subset of the features for the model to use. L2 regularization, or RIG, adds a penalty based on the squared value of the coefficients. This also discourages large weights, but unlike L1, L2 tends to reduce the feature weights without eliminating any, keeping all features but with smaller coefficients. Both methods help prevent overfitting by discouraging the model from relying too heavily on any single feature. Sometimes, a simpler approach is better. When working with smaller datasets, a less complex model, such as a decision tree or logistic regression, might actually outperform a deep neural network, as complex models are more likely to overfit the data. Computational resources can be a significant bottleneck, especially when working with large-scale models or deep learning architectures. Not everyone has access to high-performance hardware for training these models. Two common types of hardware used for training AI models are GPUs and TPUs. GPUs, or graphics processing units, were originally designed for rendering images in video games, but they're now widely used in AI development because they can perform many calculations simultaneously, which is essential for training large AI models. TPUs, or tensor processing units, are specialized hardware developed by Google specifically for machine learning tasks. They're designed to accelerate the training of deep learning models, and they're even faster than GPUs for certain types of computations. If you don't have access to GPUs or TPUs, you can use cloud platforms like Google Cloud Vertex AI, AWS SageMaker, or Microsoft Azure Machine Learning. These platforms offer scalable cloud-based infrastructure so you can rent the necessary compute power instead of buying expensive hardware. Alternatively, you could opt for efficient algorithms that don't require as much computation. For smaller datasets or tasks, models like random forests or support vector machines might be sufficient, and they're much less resource-intensive than deep neural networks. Another effective strategy is transfer learning. With transfer learning, you use a pre-trained model, one that's already been trained on a large dataset, and fine-tune it for your specific task. This significantly reduces training time and the amount of computational power required. As AI models become more complex, it's also important to consider interpretability, that is, understanding how the model arrives at its predictions. Some models, like deep learning networks, are often referred to as black boxes because it's difficult to explain their internal decision-making processes. Two tools that can help with interpretability are SHAP and LIME. SHAP, or Shapley Additive Explanations, assigns each feature in your model a Shapley value, which represents its contribution to a specific prediction. By breaking down the model's output into contributions from each feature, SHAP helps you understand why the model made a particular decision. LIME, or Local Interpretable Model Agnostic Explanations, explains the predictions of any machine learning model by approximating it with a simpler, interpretable model in the vicinity of the instance you want to explain. LIME essentially zooms in on a small part of the model's decision process to make it more understandable. In some cases, you might choose to use simpler, more interpretable models. For example, decision trees or linear regression models offer greater transparency than deep learning models and can be preferable in scenarios where explainability is essential. Let's talk about AI ethics and bias. As AI becomes more integrated into everyday life, ensuring fairness and reducing bias in models is crucial. One way to mitigate bias is by ensuring your training data is diverse. If your data only represents a narrow subset of the population, your model may not perform well for other groups, leading to biased outcomes. Make sure your dataset includes examples from a broad range of demographics and scenarios. You can also use fairness metrics, like those found in tools such as IBM's AI Fairness 360. These metrics help you evaluate your model's fairness and identify potential biases. Additionally, conducting regular audits of your models is a best practice to ensure they continue to perform ethically over time. There are development platform resources. Both GitHub and Hugging Face provide valuable resources for addressing common AI development challenges. GitHub offers code repositories for data preprocessing and augmentation, implementation examples for model optimization, resources for efficient model deployment, tools for model evaluation and testing. Hugging Face provides pre-trained models for transfer learning, datasets for various AI tasks, model evaluation frameworks, implementation guides, and best practices. In AI development, you're bound to encounter challenges, but each one is an opportunity to refine your skills and improve your models. From addressing data quality issues to preventing overfitting and ensuring ethical practices, these strategies will help you overcome common obstacles and push your AI projects forward. At newbits.ai, we're committed to helping you navigate these challenges with the support of our AI Solutions Marketplace, offering a wide array of AI models, tools, and platforms to guide you in your AI development journey. Our AI Solutions Marketplace helps you navigate these resources by curating the most effective AI solutions. We provide direct links to model repositories, and we include community feedback and use cases with user reviews. Our AI solutions are updated in real time to include all of the latest advancements in language, data, audio/vision, healthcare, robotics, and gaming AI models, tools, and platforms. Whether you're dealing with data quality or model performance issues, our marketplace can guide you to the right implementation resources while leveraging these development platforms effectively. In our next episode, we'll be discussing engaging with the AI community via the AI Hub, where you'll learn how to connect with fellow AI enthusiasts and collaborate on projects. Thank you for joining me for this episode of the AI Toolbox Empowering the Learner series. And as always, stay curious, keep exploring, and remember, it's all about the bits, especially the new bits.